So now that we've covered how to start a thread, let's take a look at the other end of the life cycle, which is basically stopping a thread. And we're going to focus here on lots of different ways of stopping Java threads. So why would you need to stop a Java thread? Why don't you just let it run to completion? Well, there's a couple different reasons. One is that you might start a long-running operation, like downloading a file, or downloading a movie, or trying to access a website, and you might say, gosh, I don't really want to spend all my time doing this. It's taking too long. I'm going to go off and do something else. So the user could get bored. They could get tired of waiting for the long-running operation to complete. Another reason, and this is more of an Android-specific reason, is that you have an activity that needs to be destroyed, stopped, or paused. And that might occur if someone does pressing the back button to move out of an app and to the app that was there before. Or maybe rotating the phone. So before you were doing some processing, then you rotated it. And in that case, you may need to stop things and start them and pause them and destroy them and whatnot. We'll talk about the concurrent app. We talked about this earlier, where if you rotate this phone, this computes the greatest common divisor algorithm for a bunch of numbers. This actually has a flaw where it'll leak threads when the orientation change occurs. So you rotate the phone, the view changes so that the computations that were running in the background are no longer being displayed, but that thread is still out there cranking away, sucking up CPU cycles, which is annoying, right? You don't want that to happen. Another thing is you might want to cancel other computations when you get the answer you want. If you recall the invoke any method that was part of the executor service, it would take a collection of callables, run them all concurrently, and then whichever one finished first, it would say, thank you for that answer. I'm going to cancel everybody else. And so in that particular case, that would be an example where you want to cancel the other threads because you've already found the answer that you need. OK, so those are reasons why you might want to cancel threads. Stopping Java threads or canceling Java threads is surprisingly hard. And I like to call this the sorcerer's apprentice problem. Hopefully, you've all seen the classic Disney movie Fantasia, which has the classic scene, the sorcerer's apprentice. If you've never seen the movie, you can watch this YouTube link to learn about a bit more about it. But basically, in a nutshell, Mickey Mouse is the sorcerer's apprentice. Mickey Mouse is basically like a grad student, and his advisor has told him, fetch the water from the well and put it somewhere, right? Fill up something with the well water. Well, Mickey, being a clever grad student, decides he doesn't want to do this work himself, so instead he enchants a broom to do the work for him. But the broom won't stop. He can't stop the broom. The broom keeps taking the water from the well and dumping it someplace, and pretty soon it starts to flood, right? So what does he do? He takes an axe and he chops up the broom into little pieces. But unfortunately, all the pieces come to life, and so now there's like more and more water being pulled out of the well and thrown into his room, and he's about to drown. And then finally, the sorcerer comes back and saves him at the end. But the point is that stopping things is often harder than setting them into motion. So it's easy to start a Java thread, but it's sometimes hard to stop it. Ironically, there is no safe way to stop a Java thread involuntarily. So there's a method called stop, but it's been deprecated. It's been deprecated for like 20 years, but I think it's still lurking around. But you're not supposed to use it. And the reason why you should not use it is that it's inherently unsafe. And the reason why it's inherently unsafe is that if you stop a Java thread, then as it's being terminated involuntarily, it gets its revenge on you by basically unlocking all the locked monitors. So if you had a thread stack with a bunch of method calls that were in monitor critical sections where they'd acquired locks, it'll just go ahead and unlock those locks as the exception propagates up the stack. So any of the state that was being protected by those locks is all of a sudden not being protected anymore. So if any other threads are trying to access that state, it's in some bizarre state. The state is in a bizarre state. And so weird things will be happening, and it'll be unprotected, and it can be inconsistent because, as you all know, you're not supposed to access shared fields unless you have the locks properly held. So chaos and insanity will ensue. And another problem with stop is that there's no way to stop. You can't say, I'm now going to go into some super important critical section, and I do not want to be interrupted under any circumstances. And sadly, if you call stop, Java's like, oh well, you're gone. So obviously, that's going to cause all kinds of problems. So how do we solve this conundrum? How do we solve this issue? Well, operations that run for a long time in a thread have to be explicitly coded to stop themselves voluntarily. So if you're doing a long-running computation in a thread, then you have to periodically check to see if you've been told to stop. So you have to cooperatively and voluntarily do this. And there are two ways to stop a Java thread voluntarily. One way is to use a so-called volatile flag, and we'll talk about that approach in more detail in just a minute. And what you do here is you basically have a flag that you set to true. You have a flag called m_is_stopped, which starts out as false, and you keep looping, doing something while you haven't been stopped, and then when you're stopped, it'll transition and make it basically shut down. So that's one way to do it. We'll talk more about that in a second. And then the second way to do it is to use a Java thread interrupt request. And this is a mechanism that's built into the Java runtime environment, and it actually sets a flag called the interrupted status, which other parts of the code are then obliged to test to see whether or not someone has asked them to be interrupted. Now, as you'll see, stopping a Java thread voluntarily requires cooperation between the threads. So you can't make this work if one thread just says, the heck with you, I'm not ever going to check to see if I've been interrupted. I'm just going to keep going full speed ahead. The whole thing doesn't work. So the thread, therefore, must periodically check to see if it's been told to stop. And as a result, this mechanism is rather fragile because everybody has to follow certain usage patterns. We'll talk about those usage patterns here shortly. Voluntary checking is somewhat tedious and error-prone, but it's really the only reliable way to halt Java threads. So you don't have much of a choice. You have to do this. You have to learn how this stuff works. OK, so that's the end of that